So in this video, we're going to continue graphing quadratics starting in the root form. But we're going to look at a much faster method for finding the vertex after you plot the roots than having to convert to standard form and then complete the square. So I want to start by redoing the problem that we ended with in the last video to show you how much faster this new method is going to be. So the first thing we're still going to do is plot the roots of the graph. To get y equal to 0, we will set x equal to -1 or set x equal to 3. So those are the roots. Now, believe it or not, we already know the x-coordinate of the vertex just using these two roots. So to think about how we already know that, let's draw in the axis of symmetry. Now, how do we draw in the axis of symmetry when we don't even have the graph drawn yet? Now, the way you might have thought about it previously was, well, once we draw the graph, then we can see where the middle of it is, and we can draw a vertical line right through it, and that'll be our axis of symmetry. But we actually already know what the middle of the graph is because these two roots are on the same y value, and since the curve of the parabola is the same on both sides, then these 2 points, because they're at the same y value, they have to be an equal distance away from the center of the parabola. So we can see that the center of the parabola is going to be right here on the line x equals 1. So that's going to be our axis of symmetry. It's right in between the two roots. So what do we know about the vertex? Well, we know the vertex is the starting point of the graph, and it is somewhere on this axis of symmetry. So the only thing we don't know about the vertex is the y value. So how are we going to find that? We know the x value of the vertex is 1. Well, it's simple. We're just going to use this equation. We know that the x value of the vertex is 1, so all we have to do is say y equals, and now change all of the x's to 1. We're just substituting in 1 for x. Y equals 1 plus 1 times 2 times 1 minus 6. So here we'll have y equals 2 times -4, which will be -8. So now we know the y value of the vertex is -8, and we just plot it right on this axis of symmetry. It's going to be right down there. And look at that. There are our 3 points. 3 points is all we need to draw a general idea of what the graph is going to look like. Much faster than doing the standard algebraic method of completing the square. So now these root form problems are actually going to go really fast for the most part. Okay. Let's take a look at this one. First thing we want to do is plot the roots. So how do we get the roots? Well, we know the roots are the x-intercepts. That's what we call the points where the graph crosses the x-axis. We call the x-intercepts, or the roots. And on the x-axis, y equals 0. So in order to get y equal to 0, x could be -1/2, -1/2 right there, or -7/2. Again, if you're ever unsure of how to get this term equal to 0, you can just set up the equation 2x plus 7 equals 0. But I'm assuming by now you can see in your head, you can quickly solve that equation and see that making x equal to -7/2, basically all we did is divide 7 by 2, and then since we were moving the 7 to the other side, we made it negative. But anyway, with practice, you'll be able to see that very easily if you don't already. So here are our two roots. So where's the center of the graph? Well, we can see that these are 3 apart. So the axis of symmetry and the vertex are going to be 1.5 away from each. So this is -1/2, -3.5. So they're going to be right in the middle on x equals -2. So we don't have to draw on the axis of symmetry again. We know it's going to be x equals -2. And now we're just going to substitute -2 in for x in the equation. So we'll get y equals -2 plus 1/2 times 2 times -2. That's -4 plus 7. And this is going to be -3/2 times 3, which is -9/2. We multiplied the numerator times the constant. -9/2. So the vertex, here let's write it out as a point, is -2, -9/2. And plot that point. Now, here's what's really interesting and helpful, is that because we ended with a y value that is a fraction, that means that completing the square would have been very challenging, because we would have been dealing with fractions and completing the square, and we did do some of those problems when we were going over completing the square, and they took quite a while, a whole page of work sometimes. So this is so much faster. You know exactly where your vertex is just by plugging in for x. And there we go. Okay. So for this one, same thing. The roots are going to be 2 and -1. What is right in between 2 and -1? Well, these are 3 apart once again, so it's going to be 1.5 away from either point. That's going to be 1/2. So now we have the x coordinate of the vertex is not an integer, so it's not on the grid lines, just like the y coordinate was up there. But it's not too hard to substitute in a fraction into this equation. We'll just get y equals 1/2 minus 2. 2 times 1/2 is 1 plus 2. So this is going to be -3/2 times 3. Oh, looks like we're getting the exact same y value. It's going to be x of 1/2, y once again of -9/2. So now you see that this vertex is not an integer in its x or its y coordinates, so it's right in the middle of these grid lines here. Just means that completing the square in the old method would have taken even longer. So this is definitely the way to go when you're starting in this root form of 2 factored terms. And don't worry, we will get to problems where we're using this method but not starting in root form. Not in this video though, in the next video, because this is going to be our last problem here. Okay, so for this term, we can clearly see that we need to make x equal to 2 in order to get the whole term equal to 0. But what about this? This is a term right here, -1/6 x. How do we get that equal to 0? Well, it's simple. We just use the same logic. Anything times 0 stays 0. So if we make this x here equal to 0, then -1/6 times 0 and whatever else is here is still going to be 0. So with this x, we're making it 0. So here are our two roots, 0 and 2. Very easy to see that the axis of symmetry and the x coordinate of the vertex are x equals 1. So we just substitute in 1. -1/6 of 1 is -1/6 times 3 times 1 is 3, minus 6 is -3. -1/6 times -3 is +1/2. So what do you notice here? Now the vertex is higher than the roots. It's above the x-axis, which means this parabola is pointed downward. So it's going to look something like that. And the reason I'm drawing it so wide is because although the vertex was above 0, above these two roots, it was only 1/2 above it. So you have to be able to see that because the curve is very wide in that little area, it's going to be very wide for the whole graph. Because if we go back here and look at something like this, well, the vertex was it was farther apart. Well, the roots were a little bit farther apart too, but not by much. The vertex was much, much farther away from the x-axis, though, which means we ended up with a narrower graph, because if it's narrow at the start, it's going to be narrow all the way through. Here, the vertex was just barely above the roots, so it's pointed downward, but a very wide curve. And, of course, anytime you're graphing, any graph, not just a parabola, but if you're ever unsure of what it looks like after you've found the main points that you're plotting, you can always just plug in values for x and y, make a table, and substitute numbers into the equation. Probably you're going to pick values for x, plug it in, and then see what y equals and plot those points. The reason I don't do that is because I think it takes longer, and there's almost always a way to graph without doing that. But that is the way a lot of people will tell you to do these. So you can always do that. That always does work. Anyway, we're going to do harder problems that take a little more work using this method in part 3.